Dear colleagues, it's a privilege to be here and talk about this task, LAA Occlusion, new devices, new evidence, emerging methodologies, what is new. And I think the question is really, if you have the chance to design a device which is perfect, what are the requirements? I think it's worth thinking about a second, because that's the setting for all new devices. It should be absolutely safe. It should be easy to apply, and ideally it should occlude the left atrial appendage completely. There should be no or very short anticoagulation, as you heard, so you don't have any problems with bleeding, and you should have ideally rapid neoanesthetization of the device, so you don't need anticoagulation. It should be at least non-inferior, better superior to the novel oral anticoagulants for stroke. It should cost nothing. Yeah. This is a task for the industry. And minimal training required. One implant, perfect. So this is the setting. So what can we learn from others? And I think the surgeons taught us something about clothing the left atrial appendage. And I think they started very early on occluding the left atrial appendage. And what they thought, if they suture or staple the left atrial appendage, they get rid of the problem of embolization. But what we found is actually, if you do a surgical exclusion or suture exclusion or stapler occlusion of the left atrial appendage, there's still often remnant left atrial appendage, and sometimes they have persistent flow, and even worse, you can have the occurrence of LA left atrial appendage thrombus in incomplete occlusion of the left atrial appendage. And you can see this in a case where you have suturing of the left atrial appendage and you find a thrombus in the tip of the incomplete occluded left atrial appendage. So the most important goal of any device is basically complete occlusion of the left atrial appendage. So we don't want to have a remnant left atrial appendage. So this is the setting for new devices. And Michael Lesch came up with the first device, that was the Plateau device, which was implanted the first time in 2001. And as you can see, this device was designed to occlude the left atrial appendage completely. And there were some publications on the success rate and the feasibility of occluding the left atrial appendage, but there came other problems. And the other problems were, as Thorsten alluded on, were device embolization, perforations, pericardial effusions, and sometimes we had thrombus formations on the device as well. So the next generation which was developed was the Watchman Device, which should overcome some of these problems, but even with the Watchman Device, there were the same problems with embolization and thrombus formation on the surface, and now they try to improve it with a fourth generation device, which has a closed distal frame component, so you have a little better stability, potentially less embolization, and the change in the design with respect to the barbs allows full recapture and redeployment of the device, and now they will evaluate it in the further trial. And this was the setting for for another device, which was developed by AGA. As you can see, this is the cardiac plug, and the cardiac plug has the advantage of sealing the orifice with an additional disc, so you potentially have a complete occlusion of the left atrial appendage and potentially can avoid the formation of a de novo remnant left atrial appendage niche. And this device is further developed in a second generation cardiac plug device. And these are some images from the more recent publication on this device. And you can see that the new device has some common features with the older device, which is called the ACP1 device. The new device is the ACP2 device. So both devices have a distal lobe, which anchors to the body of the left atrial appendage. We have a proximal disc, which seals the ostium of the left atrial appendage. As I alluded to, there's a connection between the lobe and the disc, the waist. We have a nitinol mesh and 2 polyester patches sewn on the lobe and the disc. And the new features that potentially facilitate device deployment and increase safety, it's that it is a preloaded system, so air embolism may be avoided. We have a larger disc diameter to completely occlude the left atrial appendage. We have a longer lobe length to facilitate stability. We have a longer waist length, so we have less pressure on the body of on the lobe, and we have larger sizes available, so we can occlude larger appendages, which is certainly a problem in appendages which are larger than 30 millimeters. And in addition, we have a new inner delivery cable, which gives us the chance that we have a tension-free state evaluation of the device. And you can see this flexible delivery cable right here. And if this flexible delivery cable is released, then you can see the device in a tension-free state and evaluate it. There are other devices on the market, although there's little human experience with endocardial new devices. One is this Aquatech device, which has a self-expanding nitinol meshwork, including a PET patch. And in contrast to the other devices, it has loops, as you can see here on the patent drawing, for fixation. And to my knowledge, they have some animal studies, but no human studies yet. But the size devices are quite similar to the devices which you see with the Amplatzer or the Watchman Device. There is one potential feature which comes close to the tension-free, to the inner delivery cable. That's this safety delivery system with a Aquatech connector, and you can see that it probably allows to tilt to an angle of 45 degrees, so you have less tension on the device. But we will need to see whether this allows us better implantation of this device. There's another device which was occluded, which was implanted already in New Zealand, first of men study. That's the Corex medical device. You can see it here. And this device was initially implanted, and then this first in men study was halted due to some troubles with the device. Another device which was actually invented by Sideris is called the Sideris patch. It has some advantages because it's frameless, it's balloon deliverable, and it's adjustable for different shapes and size of the left atrial appendage. And it is a wireless design, minimizing the risk of perforation, which is definitely a risk when you have a design which has barbs or which has hooks. And there is a registry since 2005. To my knowledge, they have implanted around 30 cases. So it's not a lot of volume with this new device. And you have 2 other photographs of this device showing how the device actually works. So the real potential advantage is that you don't have foreign material which remains in the left atrial appendage. There are other devices you can see the PFM, left atrial appendage occluder. That's the patent. The drawing looks rather strange. And I know that they did animal studies. To the best of my knowledge, I don't know that they have implanted humans yet. And there were, this is a new concept of anchoring, because the anchoring system does not use real hooks, but there were embolizations with this type of anchoring systems in the dog model as well. There's another patent which is held by the Gore company, and you can see this is a stabilizing system which is sort of self-expanding, and we don't know yet whether this has advantages in the left atrial appendage. Apart from endocardial solutions, we have epicardial approaches as well, and certainly the surgeons now learn themselves, so they have new stapling devices which seem to be a little safer and have complete exclusion of the left atrial appendage. Then there's a mixture actually of an endocardial and an epicardial approach. That's a Lariat device. I'm actually not quite convinced of this device because we need double approach, we need transeptal puncture, and we need pericardial puncture. And then we have this rendezvous system, which most of you probably have heard of it, that you have a magnetic system and you connect both cables, and then you loop over a balloon and you basically snare the left atrial appendage. There was another epicardial device which was actually first used by Professor Cook in Hamburg, and that was called a left atrial appendage grasper, and with the potential of one fits all, but this study was halted as well because it was not feasible to use the device in all left atrial appendage. Another epicardial approach is developed currently by Dr. Holmes from the Mayo Clinic. They use an ECG-guided left atrial appendage grasper, and I know that they performed a number of animal studies, and we need to see whether this device transfers into clinical practice. And if you go into the internet and you read all these patents, you can read up to 20 or 25 different patents. You find a lot of strange designs now on left atrial appendage occlusion device, and I want to sum up finally. So we have new epicardial devices with potential for less risk of perforation. We have new second generation endocardial closure devices which are currently under investigation, and we need to see what future brings. Thank you very much.